So in order for us to calculate the confidence interval, which is a statistical concept of the frequent value of 95% can be. This is the intervals. We're gonna calculate primarily the mean of all of these values, all of this. For example, every trimester, here we have 10 every trimester, or this we're gonna have the same result if we calculate this one, because this one is the mean of all of 10 values of the price of action. So primarily we're gonna calculate the mean. So we're gonna call the function mean. We're gonna call here the function the mean, and we're gonna select 10 of them. We're gonna press enter. We're gonna finish that one. Okay, no problem. We're gonna take only 2 after the point, 2 point values. So we have here 176.18. Now what we're gonna do, we're gonna calculate the confidence interval in the of 95% because the most frequent one is 95%, and we're gonna explain it in the with pencil and paper. So what we're gonna do is we're gonna program it in the R program, and then we're gonna calculate, we're gonna explain what is the concept or how we're gonna interpret this. Okay, so we're gonna here we're gonna here RStudio. It's easy, you can search how to install it. Here we're gonna enter the variables. Here we have the x, which is the confidence, the interval of the mean of the sampling. Okay, here we have 176.18. The next thing we're gonna search for is we should enter the standard deviation. We already calculated here. This is it. The standard. Oh, sorry. I read it in French. Standard deviation. Okay. 26. It's 26.6. We're gonna enter it here. We're gonna call it SD. 26.6. Okay. And we're gonna search for the number of values we calculated, all of them. So we have here 1, 2, 3. So we're gonna calculate the sum of it. How many values we have here? It's called NB number. We're gonna select all this value right here. Okay, we're gonna press enter. It's 210 values. We're gonna enter here N. It's 210. Okay. Now what we're gonna do is we're gonna calculate the margin of error. Now to know what is the confidence interval, we have a formula to calculate the extreme inferior value of the interval, the extreme superior value of the interval. Okay, and the formula is just, I'm gonna say it, it's the mean. It's x bar minus we're gonna approximate it into normal law distribution. Normal law, it's the famous one, the most it's not which is called the normal law distribution. Okay, we have for the quantile we have here is 95%, which means it's bilateral. So we have u which is sign for the normal law minus with the quantile it's 1 minus alpha. Alpha it's we have here the 95%, which is we're gonna take the other extreme 0.95, which is 95%, and the other initial one it's 0.05. We're gonna take it we're gonna divide it by 2. 0.05 divided by 2, which is 0.025. Okay, multiply by the standard deviation, which is this one right here, divided by the square root of n, which is 210. I'm gonna explain it in the details when the pass in paper to know it. Just we're gonna program it right now, and we're gonna explain it in pencil of paper later to understand it very well. Okay, so the margin of error, which is minus plus, here we have x bar minus u, the content of 1 minus alpha divided by 2 multiplied by the standard deviation divided by square root of n. This is the margin of error. Every for the extreme inferior value x minus this error, and the extreme superior x plus this error. Okay, we're gonna show it right now. The error it's x, it's no sorry, it's key norm. This is the how we call for the normal law distribution. It's key norm minus point 9. We have here 1 minus alpha divided by 2. Alpha is 0.05 because we call for 95% of confidence. Okay, it's 1 minus 0.05 divided by 2. It's 1 minus 0.0525. It's 0.9075. Okay. Here we're gonna calculate multiply by. Sorry. Square root square multiply by so multiply by st, the standard deviation, divided by square root of n, which is we're gonna get square. This is the square root of n. We're gonna enter. No, we're gonna select, we're gonna enter this. We should enter this. Okay. We're gonna take this away. Now what we're gonna do, we're gonna calculate the extreme inferior value of interval in the extreme separate, which is x minus the error here and x plus the error. I'm gonna call enter. It's 172.58, and this one is 179.77. So we're gonna interpret it in the in level of confidence of 95%. It's a level of confidence. It's not a proportion of 95, okay, percent. And the level of confidence of 95%. The value of action fluctuates between 172.58 in 177.77. So what we're gonna do is we're gonna explain in pen of paper how with details this confidence interval of the mean. Okay, we see you in so bring pencil and paper with you